Hello friends, welcome to the course on C programming. In this part of the video, we are going to cover the chapter array and string. The chapter has been divided into three parts. In fact, we are going to make three different videos. The first video, which is this video, will be covering single dimensional arrays. In next video, we'll be covering multi-dimensional arrays. And in last, we'll be covering a string, a special array which is comprising of characters. So let's start with some basic questions which we are going to answer in this video. Why do I need an array? What is an array and how do I use arrays? So first question, why do I need array? So for that, let us take a simple example. Let's say a variable a is declared as integer a. Now if I assign a value 5 into a, it will look like this. We have the value 5 into the variable a. Now if I assign 10 into a, what will happen? The previous value of 5 will be overwritten by 10. So this previous value of 5 is gone. So there is no way you can recover this last value. So this is the problem. Now the simple solution to this problem is you can have two variables. Let's see that. We have two variables a and b. I can put 5 into a and I can put 10 into b. So now a contains 5 and b contains 10. Now what if we have such hundreds or thousands of different numbers to store? So this is an issue. So for that, let us take a very simple example. This example we have already seen in our previous videos of loop. This is an example of reading 5 different numbers and adding them. So we have a simple variable num in which we are going to read all these numbers, and the sum is nothing but it will be holding the final summation. So I am repeating the loop 5 times. I equal to 1, I equal to 2, I equal to 3, I equal to 4, I equal to 5. And 5 times I am reading different numbers, and then the numbers which we are going to read will be added into sum, and after the process of repeating this 5 times, the final summation, the final answer will be displayed. So if I run the output, it will first prompt me that enter 5 numbers. So it will give me this message in my output screen, enter 5 numbers. Then if I enter 50, this 50 will go in num, and that 50 will be added to sum. The previous value of sum was 0, so 0 plus 50, 50. Next time I equal to 2. So second time when I enter next number, let's say 60. So that 60 is added into the previous value of sum, which was 50. So 50 plus 60, and likewise all these other numbers 40, 80, 70 will be added into the sum. And at the end, when it comes out of this loop, when I becomes 6, then it will print addition equal to 300. 300 is nothing but addition of 50 plus 60 plus 40 plus 80 plus 70. Now this is a very simple program to understand. So this is just a dry run. Every time I'll be entering different numbers, 50, and that is added to 0 plus 50, then 60, so 50 plus 60, and likewise I'll be getting at the end 300, which is nothing but the value of sum, and that is displayed in output. Now the question is, now this is very interesting to understand. What if I am asked to print all the 5 numbers after printing sum? That means after printing this line, if I have to print all this number 50, 60, 40, 80, 70, is it possible to print all this number? No. Why? Because these numbers are stored in a single variable called num, and the moment for example, initially num holds 50. The moment 60 is assigned into num, the previous value of num, which is 50, is gone. It is overwritten. So at any point of time, num holds only one value. It cannot retain the previous value. So this is an issue. So this is the explanation that I have just given, that because num is a single variable, you cannot hold multiple values, and the moment you put second value, the first value will be gone. So somebody may suggest that can we use multiple variables? Can I use num1, num2, num3, num4, num5? Yes, we can use. Yes, we can use. But the problem with these 5 different numbers is we cannot use the loop. For that I have to write separate 5 statements. Scanf percentage d ampersand num1, scanf percentage d ampersand num2, scanf percentage d ampersand num3, num4, num5, and I'll have to write a statement like sum equal to sum plus num1 plus num2 plus num3 plus num4 plus num5. So this can solve my problem temporarily with these 5 numbers. But the issue is, what if we have 10, 50, 100 or even 1000 numbers? So we cannot have 1000 variables and we cannot write 1000 scanf. So this is the issue, and the solution to this issue is array. So what is array? This is simple analogy. For example, a group of cow could be considered array. Group of buffaloes could also be considered as an array, but a group having maybe mixture of cow and buffalo cannot be considered as array. So the third is not an array. So with this simple analogy, now let us try to understand the definition of array. Array is a group of elements. For example, in our previous case, a group of cows, a group of buffaloes. But the issue is having same data type. Means if it is a group of cow, you cannot have buffalo in it, or if it is a group of buffalo, you cannot have cow in it. So the data type, the group type should be the same, and sharing a common name. The entire group needs to be given a single name. For example, group of cows can be given a name, let's say COW, cow, and group of buffalo can be given a name, let's say buffalo. So a group means, for example, in our previous case there were 10 cows in the first group, and type, they needs to be of same type, means either they were all cows or were all buffaloes. And common group name, as I said, the cow for first group could be the common name and buffalo could be the second group. And how do I represent with array? We'll be writing in square bracket. Cow is the group name, and when I write 5, cow square bracket 5, it refers to the 5th cow in the array named cow. And if I write buffalo 8, it refers to the 8th buffalo in the second array named buffalo. So now let us try to understand how we are going to use in our C programming. So first thing is declaration. So how do I declare them? The marks. Let's say marks is nothing but an array, and in square bracket we specify the total number of elements in that array. So over here I have specified 5. That means there are 5 elements in this array, in this group, and all these elements are of type integer. That means there are 5 integers, there are 5 integer variables in this array marks. So variable, of course we have one integer num, and then we have marks 0, marks 1, marks 2, marks 3, marks 4. Here important thing is to note is array always starts with the 0 index. I repeat, array always starts with the 0 index. So 0 itself is a number here. So marks 0 is the first element, marks 1 is second element, marks 2 is third element, marks 3 is fourth element, and marks 4 is fifth element. So these are 5 elements. Right now we have not initialized this, means we do not have any values into these variables. So the values are question marks, and because these are of integer type, we know that integer has 2 bytes of size. So every variable, this num is having 2 bytes, and this entire group is having 10 bytes, because 2 bytes each for this variable. So 2 plus 2 plus 2 plus 2 plus 2. So total size is 5. So then total size of this array is 5 into 2 is 10 bytes. Now let us see how do we initialize an array. So the same example, integer num is 10, it is just a single variable. Now marks 5 is equal to, now in curly braces we will be specifying all values of the array. So 50, 60, 40, 80, 70. So let's see how does it look like. So we have the same 6 variable, num is the first variable, and 5 variable of this array, marks 0 to marks 4. And then if I see the values, then num is having 10, then marks 0, 0, as we know that array starts from 0. So mark 0 contains 50. This is the 0th element, first element, second element, third element, and fourth element. So marks 0 is 50, marks 1 is 60, marks 2 is 40, then 80, and then 70. So this again the size will be the same, 2 bytes each for every variable. Now let's move further. So how do I use array? So for that, let's go back to the previous example wherein we read 5 different numbers and we added them together. So this was very simple example that we have just taken. I'm not repeating it. The dry run is very simple. Every time I'm reading different numbers, these numbers are added into sum, and at the end the final summation is printed, which is 300. Now the same example now I am doing with arrays. So let us try to identify the differences. Over here in previous case we had only one variable. It was a simple variable num. In this case now we are declaring an array. So integer num5. So now this is not a single variable. It is a group of elements having 5 different numbers. Number 0, number 1, num2, num3, num4. And then of course the other things are same. So now because as we know that array starts with an index 0, rather than starting the loop from 1 to 5, we'll be repeating from 0 to 4. So for I equal to 0, I less than or equal to 4 plus I, and then rather than simply reading num, I'll be reading ampersand num I. Means initially num 0, then num 1, num 2, num 3, num 4, and then all this num will be added to sum. So over here the good thing is, in previous case num was the only variable. So the moment it reads, let's say 60, this 50 is gone. The moment it reads 14 num, this 60 is gone. But in this case the good part is we have different variable. Num0 is a different variable, it holds 50, num1 holds 60, num2 holds 40. So all these variables, 5 variables, hold 5 different values. So there is no point in overwriting anything, there is no point in losing any data. So now again it will work in the same fashion. All these numbers are added in sum. So at the end the output will remain same, 300. So output will be 300. Now let us come back to our previous question. So if I add a simple loop over here, let's say after printing addition, if I add a loop, let's say for I equal to 0, I less than or equal to 4 plus I, and if I print all these number, I'll be getting num0, num1, num2, num3, num4, which was not possible in this simple case, because in the last case, in the simple case, the num is having the last value, that is 70. There is no way you can get 80, 40, 60, 50 back. It's not possible to get because they were overwritten. Over here it is not the case. We have different numbers. So if I add this particular loop in the end, I'll be getting this output. So first of course I'll be entering all these numbers, addition will be printed, and then again 50, 60, 40, 80, 70. Means if you want to process this number further in your program, you can always process them. The numbers are readily available with you, they are not gone anywhere. So this is the benefit of using an array. You can hold, you can use, you can save multiple values at any point of time. Now let's move forward, have some examples. So first example is finding out maximum element from a given array. So let's try to understand using output first. Let's say we'll be asking how many elements are there. Let's say 5 elements. Then the program would ask me to enter 5 elements. For example, I have entered 10, 50, 30, 80 and 35, and we can see that out of these 5 elements 80 is maximum, so program would give me answer max equal to 80. So this is what I want. So input is one is the total number itself, and then all these 5 numbers I'll be processing on it, and the output will be the max. Now let's try to see the program. Program is very simple. I have declared an array, I have initialized an array, not initialized, sorry, I have declared an array, integer num 10, I is for the loop, max is the, because I need to find out the max, so I have used max variable, and n is nothing but my this total elements 5. So first thing is I'll be reading element, printf total element, so I'll be getting a message total element, and if I enter 5 it will go in n. So now this n is 5, and then it will ask me enter element. So this loop will be repeated 5 times. I equal to 0, I less than 4, means I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4, and every time I am reading a number, and that number is compared with max. We have already seen this logic in our loop chapter. So that number, if the number is greater than the previous value of max, in that case the number will be assigned into max, and this loop will, this logic will be repeated 5 times. 5 numbers will be read from keyboard, it will be compared with max, and if required the number will be copied into max, and then finally max will be displayed. So this is just a dry run. I am having the n as the variable, the n, then num0 to num9, because I have declared it as 10 size. So num0 to num9, and one more variable is there, max. So I'll be having that max equal to 0. So initially I entered 10. Now we are checking 10 is greater than 0. You can now compare 10 is greater than 0. Yes, it is greater than 0. So that 10 is assigned into max. So the new value of max is 10. Then next time 50. Now 50 is greater than 0. Yes, so 50 is assigned here. The next value is 30. 30 is greater than 0. No, so 50 will remain there. Then next value is 80. 80 is greater than 50. Yes, so this 50 will be replaced by 80. So now new value of max is 80, and last is 35. So 35 is greater than 80. No, so 80 will remain there. And by the time now 1, 2, 3, 4, 5, this loop has already repeated 5 times, so it will come out. And at that time, what is the value of max? Max is 80. So it will print max equal to 80. And these particular 5 locations will remain unused, because I declared num as 10 and I used only 5 of them. So these 5 elements will remain unused. So because this is an issue we'll be discussing later in pointer chapter, this is because of static memory allocation. Let's not go into the detail of this word right now, but this is something wherein we need to tell the compiler in advance that how many numbers do I need. So because over here I have declared it as 10, and now if I use 5, the other 5 will remain unused. This is nothing but wastage of memory. We'll come to this in the later part of this course. So again, if I change the maximum word with minimum, everything will remain same, everything is fine. The only thing is max is replaced by mean, and logic, rather than num greater than mean, it is num less than mean, and at the end I'll be getting, so which is very simple, I'll be getting mean equal to 5. So I'm not going into the detail. You can have a dry run as we did in our last example. So next example is to count number of odd and even elements. So for example, few numbers are given. Let's say 10, 51, 30, 80 and 35. 5 elements are given, and we know that 10, 30 and 80 are even numbers, whereas 51 and 35 are odd numbers. So there are 3 even numbers and 2 odd numbers. So you need to count them. So this program should display the total number of even elements in the list and total number of odd elements in the list. Now again, this is a very simple program. We have declared one array A10 and 2 counters, even counter and odd counter, which are initialized to 0. Now first we ask the user to enter the total number of element, so it is 5, and then now I am repeating this loop 0 to n. Every time I am entering a different variable, A0, A1, A2, A3, A4. So 5 different elements will be read from A0 to A4. Now to check whether it is odd or even, what do? We try to divide the number by 2. And if the remainder is 0, we know that modulo operator gives you the remainder. We have seen in our data types and operator chapter. So if AI modulo 2 equal to 0 means if I divide a number by 2 and if the remainder is 0, in that case the number is even. So I'll be incrementing the even counter. Otherwise, if the number is not even, it has to be the odd one. So in other case, I'll be incrementing the odd counter. So at the end, I'll be displaying even and odd. Let's try to see this. So again, this is the same figure. We have number 0 to number 9. And then this n equal to 5, odd and even are initially set to 0 because these are the counters. So now let's take 10. So we know that 10 modulo 2 equal to 0. Yes. So in that case, I'll be incrementing even. So look at this, even is incremented by 1. Then next time 51. I know that 51 modulo 2 equal to 0. No, it is false. So in that case, odd counter will be incremented. Next time 30. So 30 modulo 2 equal to 0. Yes. So in that case, even counter is incremented. So look at this, 1 is incremented by 2. Next time 80. So again 80 modulo 2 equal to 0. Yes. So even counter is incremented by 1. So now it is 3. And last is, let's say 35. So 35 modulo 2 equal to 0. Yes. No, sorry. In that case, odd counter will be incremented. So it was 1. Now it is 2. So now this has processed 5 times. So when I come out of this loop, the even counter holds 3 and odd counter holds 2. So even equal to 3 and odd equal to 2. And again, as in our last case, this 5 variables will remain unused. Now let's go next. So again, with the same example, we can find out positive, negative and 0 elements. Let's say in this case, if I need to process 6 different elements, and if these 6 elements are 12, minus 9, 0, 33, 44 and minus 8, in that case we know positive 12, 33 and 44 are positive numbers. So there are 3 positive numbers, minus 9 and minus 8, 2 negative number and 1 0. So this should be printed. So I'm not explaining everything. This is a very simple thing. Now instead of 2 counters that we had in our previous case, odd and even, now we are having 3 counters, positive, negative and 0. And then again we are reading everything, and what we are checking, if the number is greater than 0, positive plus plus, if it is less than 0, negative plus plus, and if it is not positive, not negative, then 0 plus plus. Just so thus keep on doing for n times, and at the end whatever may be the values in positive, negative and 0 counter are to be displayed, and you will be getting something like this depending on the values that you have entered. So this is just an assignment. You can pause the video and have a look at it later. Another example is add corresponding elements of 2 single dimensional arrays and store them in third single dimensional array. So we have, for example, 2 arrays, let's say A and B. A0, A1, A2 means there are 5 elements in A, there are 5 elements in B. The elements are 10, 20, 30, 40, 50, 15, 25, 35, 45 and 49, for example. So let's add them together. So how do we add? So first element of A will be added to first element of B, and it will go to first element of C. So C0 is equal to A0 plus B0. 10 plus 15 equal to 25. Same way, C1 is equal to A1 plus B1. 20 plus 25 is 45. And likewise for other. In general, it is Ci is equal to Ai plus Bi. And the I is to be repeated from 0 to 4. This is the simple logic. So let us try to run the program. This is something what you get in an output. For example, it will ask me to enter the total number of elements. So if I enter 5, then it will first ask me enter elements of A array. So let's say 10, 20, 30, 40, 50. Then when I enter, it will ask me to enter different elements of B. If I enter 15, 25, 35, 45, 49, then it will give me these as an output. 25, 45, which is nothing but addition of this. 10 plus 15, 25, 20 plus 25, 45, and likewise. So let us see. This is my array A, this is my array B, and this is my resultant array C. Now a simple program. I have used the color code A for red and green for B and blue for C. So first is three different arrays are declared: A5, B5, C5, and N. N is nothing but the total number of elements. So I'll be repeating the loop n times. So first enter elements of A. So I equal to 0, I less than n, plus plus I, scanf percentage D, ampersand AI. So A0, A1, A2, A3, A4. So I'll be reading A0, A1, A2, A3, A4. Next time I'll be reading B0, B1, B2, B3, B4. So I'll be reading B0, B1, B2, B3, B4. And then once I have A and B readily available with me, I'll be running one loop, I equal to 0 less than 5. So Ci equal to Ai plus Bi. So it will be C0 equal to A0 plus B0, C1 equal to A1 plus B1, C2 equal to A2 plus B2, and likewise. And then once I have my answer readily available in C, then I can display them. So I equal to 0, I less than 5. So C0, C1, C2, C3, C4. So C0 is 25, 45, 65, 85, and 99. So this answer will be displayed in output. So next example is searching an element. Again, this is an assignment, so you can refer it later. I am just explaining it briefly. Let's say first you ask how many elements you want to process. Let's say 5, and then you enter 5 different elements. The examples are 10, 20, 30, 40, 50, and then search an item. What do you want to search in this list? Let's say you want to search 40. So in that case, it should print item found because 40 is there in this list. And if so this is the simple program. I have the array A, I have I for the loop, n is total number of elements, and item is something that you wish to search. So this element is 40 will be stored in item. So first we ask total elements. So total elements equal to 5. So this 5 will go in n, and then I am reading all these 5 elements: A0, A1, A2, A3, A4. So I'll be reading A0, A1, A2, A3, A4. And then I'm also reading, I'm asking user to enter the item to search. So if the user enters 40, that 40 will go in item. And then now I am running a loop and checking this item with every element. So if AI equal to item, if it is true, means the item is compared and it is matched with a particular element in A array, then we'll be printing item found. And return means it will be end of the program. We'll be studying more on this statement return later on in function chapter. But if the item is not found, in that case it will never go in this section of this block and it will come out of this loop. In that case it will print item not found. So the first 10 is compared with 40, not found. 20 is compared with 40, not found. 30 compared with 40, not found. When 40 is compared with 40, then it will enter here and it will print item not found. And if I run the program again, let's say this time if I wish to search an element, say 29, in that case 10 is not 29, 20 is not 29, 30 is not 29, 40 is not 29, 50 is not 29, and now this is the end of the loop and it will come out and then it will print item not found. So let's move further. This is a very popular, very important and very interesting example, sorting, because you'll be needing this in rest of your course also, and in advanced courses like data structure and all other different programming languages. Sorting is a very good example to learn. So I want you to be little concentrative over here. For example, input is, let's say, these 6 numbers, and I want to sort them in ascending order. Ascending is the smallest number in the beginning, and the largest number in the end. So minus 90, 0, 2, 5, 12, 40. So this is my input and this is my output. So this is what I want to get. So now let us try to do this sorting. How do we do that? So let us start with this input 12, 43, minus 90, 0, 5 and 2. So let us start with input. Now let us have one black pointer which is starting from the very first element, and let us have a blue pointer which is starting from the black pointer plus 1. So black pointer is pointing to 12 and blue pointer is pointing to 43. Now I am comparing 12 with 43, and if blue pointer is having the value less than the black pointer, in that case we will be swapping them. So in this case no swapping is required because blue pointer is having higher value, so no swapping is required. In that case what do? We increment this blue pointer. So now blue pointer is over here at minus 90. Now let us compare minus 90 with 12. Yes, blue pointer contains the number which is smaller than black pointer. So in this case these two numbers are to be swapped. Minus 90 will go here, 12 will go here. So after swapping you can see now minus 90 is over here and 12 is. So now what do? Then blue pointer is incremented by 1. So now it is pointing to 0. Now minus 90 and 0. No swapping is not required because 0 is greater than minus 90. So what do? Blue pointer is incremented by 1. And then the blue pointer is pointing to 5. Again no swapping. And blue pointer is pointing to 2. No swapping. So if you can look at this carefully. So after this process, the smallest number has come in the beginning. So this is the first phase. Now what should we do next? Now this black pointer is incremented by 1. So now this black pointer is incremented by 1 because this first position has already got its own number, the smallest number. So black pointer now is pointing to this place, and blue pointer always starts from black plus 1. So now let us compare black pointer with blue pointer, and 12 is less than 43. So swapping is required. So 12 will go here and 43. So swapping is done. Now next blue pointer is incremented by 1. So 12 and 0. Yes, 0 is less than 12. So swapping is required. So swapping is done. Next time 0 is compared with 5. Blue pointer keeps on incrementing. You can see. So now 0 and 5, no swapping is required because 0 is already less than 5. And then lastly 0 is compared with 2. So again no swapping is required because 0 is already less than 2. So now the second lowest has come to its place. So this is the second phase. What next? Now this black is to be incremented to the next one. So now let us do that. So black is now pointing to 43 and blue always starts from black plus 1. So now look at this. Try to compare. 12 is less than 43. Yes. So these are to be swapped. So swapped. Then blue is incremented by 1. So 5 and 12. 5 is less than 12. So they are to be swapped. So swapped. And next. Now 5 and 2. Again 2 is smaller than 5. So let us swap. So now you can see the third smallest value has come to its place. Now what next? Now this black pointer is to be incremented to next position. Let's say now it is pointing to 43. And blue starts from black plus 1. Now let us compare 43 with 12. So 12 is less than 43. They are to be swapped. Yes. So swapped. And then blue pointer is incremented. So 5 and 12. Yes. 5 is less than 12. So they are to be swapped. So it is swapped. Now next. Now what next? Black pointer is to be incremented by 1. So now black pointer is over here and blue pointer starts from next. Now you can see that this should be the last situation. Right. So now compare 43 with 12. So now 12 is less than 43. So these are to be swapped. So now swap. So now if you can look, this is nothing but my complete sorted output. Minus 90, 0, 2, 5, 12, 43. Minus 90, 0, 2, 5, 12, 43. Now if we summarize this, there are total 6 elements. So if we talk in terms of n, there are n equal to 6. So the black pointer starts from 0 to n minus 2. So if this is 0, 1, 2, 3, 4. So black pointer starts from 0 and it goes to n minus 2. N minus 2 means 6 minus 2 is 4. And blue pointer always starts from black plus 1. We know that blue always starts from black plus 1. Blue always starts from black plus 1. And it goes to n minus 2. So 6 minus n minus 1, sorry. So 6 minus 1 is 5. So 0, 1, 2, 3, 4, 5. So now this is very important. To form the program, to build the logic, this is important. The black variable, the black arrow in this case, starts from 0. It goes to n minus 2. This would be my outer loop. And for every value of black, the blue starts from black plus 1 and it goes up to n minus 1. So if I call black variable a black arrow I, so I starts from 0 to n minus 2. And if I call blue arrow j, then j starts from I plus 1 to n minus 1. So if I form a loop, it would look something like this. From I equal to 0, because black started with 0, it went all the way up to n minus 2 and increment. And for every value of I, the inner loop, the blue arrow j starts from j plus 1 up to n minus 1 plus plus j. And we compare ith element with jth element, and if required we swap them. Right? I think this blue should be black and this black should be blue. There is a small mistake. So how do I swap now? For example, now I have x equal to 43 and y equal to 87. How do I swap? I cannot put directly this y into x, because the moment I put y into x, this 43 will be gone. So for that, I want a third variable. Let's say temp. So first I'll be storing x into temporary variable. So now this 43 is stored in temporary, and then now this 87 is stored in x. So now 87 will go in x. So now the previous value of x was 43, that is gone. Now it is 87. And then this temp, which was holding the value of x, now that is copied into y. So temp equal to x, then x equal to y, and y equal to temp. This is the logic for swapping. So now with this, let us write a program. The output would look something like this. First it will ask me to enter total number of elements, let's say 6, and then I'll be entering all these elements, and then it should print me the sorted list. So this is my complete program. Let's say first A is an array, n is nothing but that 6. Then I'll be entering these 6 elements, and then this is my black arrow, I equal to 0, I less than n minus 2, and this is my blue arrow, j equal to I plus 1, blue starts from black plus 1 and it goes all the way up to n minus 1. And if I compare ai with aj, so ith element black with blue, and then if required we swap them, temp equal to ai equal to aj, and aj equal to 10. So this complete loop will swap them all and it will print me the sorted value. So at the end I'll be getting the sorted value. So this is the dry run. Initially I equal to 0. This is nothing but by black arrow, and it starts from I plus 1. So 0 plus 1 is 1, 2, 3, 4, 5. And then every time I'm comparing all these numbers, you can pause this video and check whether how this logic works. And in the same thing that we have seen in our last slide would be appeared over here. First it will bring me the lowest value in the beginning, the second lowest, the third lowest, the fifth lowest, and at the end I'll be getting the entire list sorted. So with this, I thank you. I hope that you have understood the basic of array, the single dimensional array. In our next presentation, in our next video, we'll have multi-dimensional array. So thank you for watching and hope to see you in the next video. Until then, enjoy C programming.